Cool, 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 cool. Okay, so last one I want to do is the wheel rolling up a step problem. Is it number 10? Cool. All right, so like I said, this is kind of like a classic, like you would see this in pretty much any college physics class you take. So the idea is you've got this wheel, and we're trying to roll it up a step, okay? So the idea is there's a horizontal bit, and then the step goes up a little bit, and then it goes like this, right? And we're trying to roll it up a step, okay? So here's what the problem tells us. The problem tells us that the step has a height of 3 centimeters. Would it piss anybody off? Oops, I just said that. Would it make anybody angry? Sorry. If I just left things in centimeters? And instead of measuring our torque in Newton meters, we'll use Newton centimeters. Is that okay? It'll make things just a little bit easier. All right, so this height here is 3 centimeters. Oh, remember when I said I was going to use centimeters, and then I wrote meters anyway? All right, so there we go. The height there is 3 centimeters. All right. The problem tells us that the radius of the wheel is 6 centimeters. All right. It tells us that the mass of the wheel is 0.8 kilograms? I'm doing this from memory because I'm dumb. Yeah. 0.8 kilograms? Okay. And we're going to try to move this wheel up this little step by just exerting a horizontal force, F. And the question wants to know, how much force do we need? All right? So there's a trick to this. And once you see the trick, this problem is actually really easy. But you got to figure out the trick. Okay? So that's why I wanted to show it to you. All right? So let's start by identifying the forces that act on the wheel. So what forces are there other than F? Gravity, right? So 0.8 times 9.8 gives us 7.84 newtons. And I jumped right ahead and put it in. Are you cool? Is everybody cool with why I drew it coming out of the center of the wheel? Because that's where your center of mass is, right? I should have paused before I did that. But are we good with that? Yeah. Unless it says that the thing is massless. So there have been a couple problems where it's like, oh, massless strut. I don't know why they do that. But
so like easily to survive here.
Yeah. Yeah, so I talked about that a little bit yesterday. So yeah, so to reiterate, from now on, you guys, like before we used to just draw arrows pointing out of boxes, right? Now you got to draw arrows pointing out of boxes, but they have to point out of the point at which the force originates. Good? All right, so is everybody good with this? All right, so the idea is what we're trying to do is we're trying to roll the tire up the step, right? So you guys agree, once we get it going, it's going to lose this point down here where it's touching the floor. It's going to lose contact there, so there's not going to be a normal force there, right? So the only other force is going to be the contact point between the step and the wheel, right? And there's a force applied there, but the problem is I don't know what direction it's oriented in, right? So there's an unknown force that's kind of, I'm going to kind of lightly draw it. There's an unknown force kind of here. We'll call it force from step. But I don't know how big it is. I don't even know what direction it points in, right? Now, it turns out, and this is not at all obvious, that it just points right at the center of the circle. Okay? But I don't think that's obvious. So how do we solve this thing? So here's the trick. So I think usually you think of a wheel and you think of it spinning. Where's the pivot point? At the center, right? But here, no. Because think about what we're trying to do. The step is hitting right here, right? And we want it to go, ooh. What point is it pivoting about? The corner, right? Does that make sense? Okay, so that's kind of the trick there. So what I'm going to do is that little point where that unknown force is, let's call that P, our pivot point. Okay? Oh, I'm going to undo real quick. I want to get rid of some of that green there. My drawing's going to get too cluttered. All right, so here's my pivot point P. And so the idea is the applied force is trying to rotate the wheel this way, and gravity is trying to rotate the wheel that way, right? And in order to get it up the step, I need the torque from my applied force to be bigger than the torque from gravity, right? Follow? So, we are running out of time. So, to calculate these torques, we need to identify our lever arm. So the lever arm is the line that goes from our pivot point to where the forces are applied. So both of those have the same lever arm, that green line that I just drew, right? Cool? Now, if this is 0.3 meters, I shouldn't have pushed my luck. There's a little triangle here. What's the vertical bit on this triangle? Yeah, it's got to be 3, right? Because this is 6. So if this is 3, this has got to be 3 also, right? Follow? So there's 3 centimeters there. Hopefully it'll fill in a minute here if my computer starts cooperating. So anyway, what does this angle here have to be, you guys? Yeah, because if this is 6 and this is 3, this has to be 30 degrees. Come on, computer. So I don't have time for this right now. The bell's going to ring in like a minute. I'm waiting for my stupid computer. All right. So anyway, so then all you're going to do is you're going to just ensure that the torque from this force is bigger than the torque from this force. So what's that going to look like? You're going to have 6 times F times the sine of 30 has got to be bigger than 6 times 7.84 times the sine of 60. I will write it out now since my board is not working. So we need the torque from F to be bigger than the torque from gravity. So 6 is our lever arm times F times the sine of 30 has got to be bigger than 6 times 7.84 times the sine of 60 degrees. And then solve for your F. Does that make sense, you guys? All right. All right. So homework, review. Where's the review? Here it is. Shoot, I forgot to delete number 7. All right. Hey guys, I'll send out a message on Schoology. I meant to delete one of these comments. I just realized I didn't. You can skip number 7 on this. If there's a physics not Snapchat, group chat. Which might have some people from 4th hour. If somebody wanted to throw that onto the group chat, that would be helpful. I'll also put a message out on Schoology. But again, you can skip number 7. Go. I hope your weekend's okay. Yeah, I hear ya. Let's talk Monday. Okay. Somewhere. Oh, right here. I used to have 4 of them, and now I have 1.
Oh.
I don't know what happened to them all. I know Mr. Garrissey has 1 of them.
Oh, yeah.
I don't know why. No, hey,
Hi.
what you want to do? So choices are, you can take it 6 hour, 7th hour, after school, or
I'll take it after school.
cool. Can you get here right after school though? Because I'm not afraid of doing a kid's club. But my daughter's going home and I don't want to leave her home.
Okay.
Okay? Yes.
Can I take it Wednesday? Because I won't be here
Monday?
like Monday or throughout the whole weekend. I'm going to States there for that. And since I don't have that much time to study,
Cool. You're not here Monday, is that what you said? Okay, so let's talk Tuesday about it.
Okay.
Yep. Have a good weekend. Oh, I'm still recording.